Do you ever think about the future? And I don't mean your career or the next election, but about the world as a whole, decades from now. May I have a show of hands? And what about the year 2100? Okay, see, most of you put it down. If you've seen this date in the news, it probably had to do with climate change. As you may know, rising carbon emissions will only deepen the cracks already forming in global systems, from food security to international stability. Now, imagine for a moment that you're a climate scientist looking into the future. You'd see at least 2 carbon emissions pathways, one high, one low, each leading to very different outcomes for the year 2100. Knowledge of these different pathways helps shape the climate policies we make today. But here's the problem. That knowledge isn't complete. It's a bit like playing darts. We want to hit the bullseye of our emission targets. And sure, decarbonizing faster would help. But if the climate system did anything unexpected, it'd be as if the dartboard itself shifted at the very last second. And right now, this dartboard isn't exactly nailed to the wall. It's only held up by the climate data we have of the past century or so. The issue is, the climate is now moving so fast away from this baseline that we're starting to push models way beyond their tested range. But okay, here's the good news. We can actually expand that range by looking into the climate from thousands and millions of years ago. That's what I do in my PhD. I get to be a sort of historian of the Earth. Though I can't rely on human records, so my history books, they're microfossils. Turns out these tiny creatures wrote down records of how cold or warm the oceans were when they were alive. And not only that, though, they did all of this in a language that we can understand, chemistry. These records of ancient climate change will help us stabilize the dartboard emission targets. In other words, by learning from Earth's deep past, we'll be better equipped to guide its future. Thank you.